In this video, I have an application for a bag filter. A bag filter, you can find it in mostly in two areas. The first one as a control of the pollution. If you have a dust in air or some gases, then you take the dust by the bag filter, or you can collect your product by a bag filter. So the bag filter, if you can see here, consists of some bag, and the air and the dust coming from one side going through the bags, so the air will leave and the dust will go down. You need from time to time to shake those bags to get the dust out of them. So if now this is my product, you are very interested that this bag filter won't stop at all. Normally you can buy a very cheap small card which controls how the system works, and it's very important to keep it running all the time. And how it's cleaned by a pulsation of air. So air pulses goes into each one of those or group of the bags to shake it and get the dust out of it. So the problem is we have a lot of those pulses like solenoids. So a small card can't fit in the application. The second issue, if the filter stops for any reason, then the whole production line will stop. So we need a redundant system to make sure it's running. On top of that, my client wanted to make sure that he can change the pulses between 80 to 200 milliseconds. Now, I built the system in a PLC system because I tried in DCS, and DCS can satisfy the very high output. So we built it in a PLC system. As you can see, it is redundant system, and then all the output goes through the relays to the solenoids. Different cabinet, different application. It's the same bag filter application, but different places. So what is my problem? My problem is that I want to make sure that my relays will be closing and opening in the required timing. At the end, what I wanted to do is to make sure that this contact of my relay will send a pulse of 80 milliseconds to the solenoid, regardless of the PLC scanning time, on to off to on time of my cards. At the end, I need to make sure that this goes between 80 and 200 milliseconds. If I have a counter and I have a pulse generator, and the pulses goes through the contact, then probably I would be able to catch those counts. And if I know how many counts I have in a second, then I know exactly the time for this contact had been closed. So the way I did it is I built this PCB from a 555 as a pulse generator. Then I have some counters, and then the counter has output as BCD. It goes into BCD to 7 segment. So as you can see the card here, you have a potentiometer, so I can play a little bit with my pulse widths and make sure that's how many pulses I have in a second. So the idea is not having 80 pulses, but I need to have more than 1000 pulses. So I can capture as accurate as I can from my relay. So if you can look at the card here, I have two switches. So I have the pulses goes through this other switch to the counter, or it goes out to my relay and come back to the counter. But how I tested the circuit? I built a very simple program in the PLC, which is say 10 seconds or 20 seconds, and then I counted how many counts goes through my relay in this 20 seconds. Then I can divide it by 20. I can know exactly how many pulses comes in 1 second. In this particular case, which is you will see a video when it is running, it's about 1250 pulses per second. As you can see from the back, it's pre-drilled card. Here is the card while it's working, And what I will do is push this switch to get all the pulses through the counter, and you will see what is the count and how it works.